And you're still muted, by the way, Argenis. Not sure if Argenis is having a technical problem or not. I'm unable to speak to him. I'm trying to check to find out. I do know he is online as we were talking before the presentation began. Please bear with us. I got a message from Argenis' computer crash. He is working on rejoining. He should be here shortly.
Sorry guys, so apparently the Windows 10 creators update doesn't get along very well with GoToWebinar. So apologies for that. Now I have to go reconnect VPN and connect to servers and things like that. So bear with me 1 second. Can you guys see my screen okay?
We see you.
Okay, good. So bear with me 1 second. All right, I'm gonna launch some slides here. And we have slides. All right. So, guys, sorry about the technical difficulties. I don't know where we ended up. Robert, I should just take it from here.
Yep, feel free to start.
Awesome. All right. Thank you. All right, guys, this is Hacking SQL Server for Fun and Profit. Again, apologies for the technical difficulties. I have to start with a disclaimer, a big disclaimer here. Don't try this at home. This is the very first thing I would recommend. You know, this is not meant for you to try in your production systems. Okay, not now, not ever. This is something for you to try in systems that you really don't care about. If you break your systems, it's not on you. It's on you. It's not on me. It's not on the security VC leaders and volunteers, and it's definitely not on Baz. All right. But if you use any of these methods to hack someone, make sure you leave no trace, because you know good hackers leave no trace. But I'm kidding, because the NSA always knows. Anyway, about me, I am a SQL Server MVP. I also work for Pure Storage as a principal data architect. I used to be the former, I'm now a former board of directors at PAS. I used to handle the SQL Server portfolio, and I've been doing this for a really, really, really long time. So the agenda today, we're going to talk about SQL Server Forensics. Okay, we're going to talk about the different places where SQL Server saves information and the kind of breadcrumbs that you can follow. We'll also talk about how a local admin is always a sysadmin. Okay, and that's something that you should always keep in mind. If you're a local administrator on Windows, that you're always a sysadmin in SQL. We'll talk a little bit about the network sniffing. We'll talk about my favorite thing in the world, which is called pass the hash. It's an attack vector that's been around for decades, really. And then we'll talk a little bit about how to find the documented stuff on SQL Server. Okay. All right, so the first thing is SQL Server Forensics. Where is stuff persisted on SQL Server, right? So there's many places where SQL Server actually saves information. And I think, when you think where stuff is kept, where stuff is persisted, you naturally think about the data files, but you should also think about the transaction log, right? Transaction log can sometimes have even more information than the data files themselves. This is something that you probably want to remember all the time. As you make modifications to SQL Server, pretty much everything is kept on the transaction log. Naturally, there are some things that you modify that are instance-wide, instance settings, and things like that may not automatically be reflected on a transaction log of any given database. But the transaction log also can point to a lot of good information from your SQL servers. So anyway, let's look at the different places where SQL Server actually saves information here. So I'm going to go ahead and connect to my lab. So bear with me for just 1 second here while I make this work. Now I had to reboot my computer twice, so I lost all the connections that I had to my lab, etc. So bear with me for just 1 second while we go explore the different places where SQL Server I can actually save some information. Just 1 second. And lab SQL 1. I'm going to go ahead and launch my SQL Server 2016 instance here. All right, so this is not really important to what we're trying to do. We want to go ahead and close that. So anyway, this is the regular SQL Server instance. I do have some scripts I want to show today. One of the easiest ways to kind of peruse the transaction log is by using a undocumented or sort of undocumented called FNDB log. Right? So I'm actually going to show you some of that. Let's go ahead and create some. Let's go ahead and create some a new database. Right? Just any database will do. Test. It's just a default, so that is fine. We're going to go ahead and create a new table called test table. Apologies, and I'm typing in the demo here. Oh, just an identity fields in the table, nothing more than that. We'll go ahead and insert default values into that test table. And now look what happens when I run FNDB log. FNDB log is the sort of undocumented, but really it's pretty widely documented the system call that allows you to look at what the transaction log actually has saved. So if you actually execute FNDB log, look what happens now. I think I created that table with the master database, didn't I? Yes, I did. Because I'm silly, I didn't switch databases. So there we go. Anyway, so these are all the entries that we created on the transaction log from the actual rows that we inserted. So you can see here all the insertions of the rows, the beginning of the transaction for the insert of the rows, the data being appended to it, and the commit of the actual transaction. So that's fine and dandy, right? We get a ton of information out of the transaction log itself. And you can even get, you get allocation unit names, and you get some pretty interesting things from here. So the transaction SIDs, you can even tell who did what, right? You can there's actually one of the fields here that tells you exactly who did what on the transaction log. But actually wanted to show you this particular demo is probably going to be a little more interesting. So transaction FNDB log allows you to get information from a live transaction log, right? From your transaction log that's on their database that's up and running. But what if you wanted to get information out of a transaction log backup? Right? For that, there's actually a call called fn_dump_db log. And so it goes just like this. Let me just show you just a second here. There it is, fn_dump_db log. All right, so we're going to take a look at that. And this demo goes like this. We're going to go ahead and create a new database, which is first going to make sure that it doesn't exist. We're going to go ahead and create it. Please don't pay attention to the actual defaults here. I'm going to set the recovery to full. I'm just going to do that really quick. And then the other thing that we're going to do is just back it up. Okay, we're going to go ahead and take a full backup of the database that we just created. Okay, so it's going to take just a second. All right. So next thing we're going to do is we're going to go ahead and use that database that we just created. And we're going to go ahead and create a new table, test table. This one is a little more interesting than the other one. And nothing too fancy. We're just going to create an identity field and some filler data there. So now we're going to go ahead and insert two values into that table, right? By the way, this code is actually pretty useful. If you add any number next to a row, it will actually execute that batch however many times you indicate. So that's a nice tip to do that. So if I select star from dbo.test table, you can see the two rows that we inserted, and that's my version of big data for you guys. So anyway, if I now go and delete row ID 2, you can imagine that we're only going to end up with one row, right? So what happens if we back up the transaction log, right? And we execute this, what I call the best functioning invocation in SQL Server ever. Right? This is actually I call to FNDB log that will show me the operations of the log where the rows were deleted from the actual transaction log backup. So this is pretty useful, right? So if I execute that, it takes a few seconds to return. This is not particularly fast. There we go. Row log content 0 is one of the rows that fn_dump_db log retrieves. And if you guys look at that, the contents of that look like a pattern, right? And if you think in hexadecimal, that says data, 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 data. So that's a big data row kind of thing that I showed you guys before. So this is how you can actually recover data from a transactional log backup, right? This is actually what some of the tools do. These log reader tools that recover data from you. So after you've done something really awful, kind of help you recover from that. They basically just parse that information in the transaction log and try to recover the data from that. So anyway, the exercise for you would be to take that T-SQL, create some T-SQL to convert row log content 0 to a string, and then into actual T-SQL that will allow you to restore the data from there. As a matter of fact, there is somebody who's already done this. His name is Patrick Flynn. He's from a good friend from Down Under, and he's actually created a script that does this free thing. So that's pretty interesting. Anyway, let's go ahead and clean up here. So that was a quick demo for FNDB log and fn_dump_db log. There's some interesting aspects to this I may not have considered. The fact that even on a transaction log backup, you may actually get full data. So depending on the actual kind of operation you're performing and the recovery model for your database, you may actually get full extents into your transaction log backup, right? And that actually means that you can get direct data, not just the actual description of the insertion of the log, but sometimes you can get full extents in the transaction log backup. So transaction log backup can have data. And in a full backup, you actually have a portion of the transaction log that's needed to bring the database to a transactionally consistent point in time upon restart. And that means that fn_dump_db log can actually run against full backups as well, because full backups can contain transaction log. So it's a couple of interesting things there. All right. So which other places the SQL Server handle keep this information? So, well, I mean, there's many others, right? You have the SQL Server error log, for example. So in this case, I have a whole bunch of information here in this transaction log. I'm sorry, in this particular error log. You can see here that SQL Server saves a lot of information here, even from the beginning of time. Actually, I don't think I've cycled this this very well. But you can see how SQL gives me plenty of useful information here. It tells me the build numbers and what kind of server I'm running this on, et cetera, et cetera, et cetera. So I have a significant amount of information that may be interesting for your forensic purposes, right? Information such as, when somebody tries to log on to a database, and for whatever reason, the login fails. And so this is, this information that is kept on the actual error log. You can actually configure, even for successful logins, to get written directly to the error log. So if you're wondering, where the actual error log is, so the error log would actually be one of the SQL Server directories, and I believe I have that in my. Actually, the number when I have this. I don't have it here. Okay, SQL system, I believe it is. Yes, there it is. So in the SQL data and the log folder for your SQL Server installation. There you go. There you go. That's your error. Those are my error logs. Okay, so there's a simple way for you to cycle the error logs, and that will be a call to sp_cycle error log. Okay, which basically executes something called dbcc error log. It's the equivalent thing. So if you do a dbcc error log, it basically does the same thing. And so, what happens every time that you cycle the error log, the latest one gets cleaned up, right? So if you look at the latest log, it basically has very little information. Okay, and the old ones get kind of rolled into the older ones here. And so if you look at the actual error log files, you only have 7, and so it has the current error log plus 6 additional ones. You can actually change that by right-clicking on the SQL Server logs, saying configure. You can limit the number of error logs, increase that to a bigger number. I would actually encourage you to look into increasing this number to something higher than 6, because potentially you can find some forensic information that may be of interest to you if you're trying to figure out, of what happened from a particular occurrence or a particular incident in your infrastructure. Okay, and so what that's going to do is allow you to keep a larger number of error log files. And plus, your error log file can actually get pretty large. So if you're not typing your error logs today, this is something that you as a DBA may want to keep an eye on. So speaking of this log folder, you see there's a whole lot more stuff in there, especially all of these interesting files are like these XCL files. So what are those things? These XCL files turn out to be extended event sessions that are constantly running on your system. So this HK engine is actually for in-memory OLTP or Hackathon, right? And this managed backup events are actually for managed backups to Azure and things like that. There's even more files. You can actually tell which extended event sessions are running on your system by building a very simple query for select star fences DM XE sessions. And that would actually tell you which extended event sessions are running on your system. So you can see that right here. I have a whole bunch of them, even telemetry extended event sessions. And some of them you can actually do things to them, and some of them are actually internal, and there's absolutely nothing you can do with them. Okay. So you could potentially have more, you enroll your own and capture all sorts of interesting information using events. So that's another potential area where logging takes place and more information can be kept on your SQL servers. You also have the TRC files here, and you guys, if you look here, the description says trace data file for SQL Server Profiler. But it's not that Profiler is running all the time and capturing information. These are server-side traces. Okay, and the server-side trace, there's a default trace that runs on your SQL Server. It's been there since SQL Server 2005, still there today. Default trace is a server-side trace, again, not a profiler trace, but similar to it, but it runs on the server side. And that actually tracks a whole lot of information about what may be taking place in your system. So you can actually open any one of these and it will launch Profiler. And within Profiler, well, I should have launched Profiler with administrator privileges, et cetera, But you can read these files with Profiler and definitely take a look at some interesting events that are tracked like that. So whenever you do things like dropping a database, for example, and things like that, and some pretty important modifications to your system, those events are actually going to be tracked on the trace file, on the default trace. And so if you do something to a system, that information may actually be kept there. If you look here, there's another log That's a SQL agent log, which is separate from the SQL Server error log. So SQL agent itself is a standalone application, pretty much. You can think of it that way. If you go into Object Explorer and you go into SQL Server Agent, you can actually see the error logs for SQL Server Agent in a completely separate amount of logs, and they also can be configured for several different things, right? Like informational logging, it does not take place automatically with SQL Agent. But you may find some interesting information here about things that may or may not have taken place on your system, for forensic purposes. So that's yet another log. If you notice the log file viewer, I mean, this is something that's kind of underrated in SQL Server because you have access to multiple logs at the same time. You can actually correlate Windows events with SQL Server events, right? They actually get mashed up together. And more importantly, the database mail log, which a lot of us don't actually pay attention to. So if a system is sending continuous emails, and there might be some interesting information about where what's taking place on that particular instance where database mail is kind of being abused. Just looking at the log here, so that's another place where you can find more information on SQL Server. So let's see if we're missing anything. Well, yes, we are. So we're missing the actual ring buffer. So the ring buffers are they're yet another area where you could potentially obtain information from. So ring buffers are basically circular memory structures where SQL Server constantly saves information to. And if you query system.ms ring buffers, you can actually see there's a whole bunch of data in there. This returns 21,000 rows. Even on this instance, it's actually not that busy. So if you select distinct ring buffer type from ring buffers, then you can actually see the different kinds of things that are saved in the ring buffer. So you see a ring buffer from a memory broker, clerks, and you can see resource monitor, scheduler monitor, memory broker, standard events buffer states, OBG schema manager, scheduler exception, and of particular interest, there's the connectivity ring buffer, where actually may contain information that may not be saved about connections performed to SQL Server, or like things like guests are not identified themselves. So that they don't actually create an entry in the error log, or you may see some entry creating in the ring buffer on the connectivity ring buffer for that. So for example, if you query that real quick, I'm actually not going to go into too much detail on this because we're already running low on time and it's kind of insane. So if you select star from that where ring buffer type equals ring buffer connectivity, then we're going to be able to see what's saved in there. And so if you look here, there's records being created, right, with timestamps associated with them. And you can see, TDS, SNI, connectivity kind of, level kind of information. And sometimes you even get, full-blown stacks. And these stacks you kind of have to parse to understand, what you're actually reading. But it may be extremely useful in the case of performing forensics against SQL Server. Okay. All right. So that was the ring buffers, and with that, I believe we've covered pretty much everything that I wanted to talk about in regards to SQL Server forensics. Now we're going to go ahead and talk about why local admin is always necessary. Okay? There seems to be this widespread myth that you can actually establish a separation of duties between a Windows administrator and a SQL Server administrator. That is there's actually a lot of fiction to that. Anyone who has local administrator privileges on a Windows instance, it means that they basically have debug privileges on that server or that host or that guest VM or whatever, because they can basically debug the memory of any process running, and that basically means that they can see anything that SQL Server is doing at any given point in time, and they can actually do things like injecting code and having SQL Server perform whatever tasks they want SQL Server to perform. But anyway, let me show you what I mean when I say that local admin always equals sysadmin. I believe I have the SQL Server 2008-02 VM that I want to show here. Let's go ahead and launch SSMS really quick on this one. So if I connect to this, this is my pure SQL or JNet login. Right? So you can see that if I go to my security tab for my logins, you can see in pure SQL or JNet, it's actually a sysadmin in this one. So if I go ahead and delete myself. I believe I can do this in SQL Server 2008 to a newer version, so actually get an error saying that you're logged in, you cannot do it. So if you refresh this, you get an error now saying that your SQL agent no longer has access to the box. Well, since I'm a local administrator on the box, I have privileges to run pretty much anything I want. I'm going to actually leverage something called PSExec, which is a utility from sysinternals. Right? If you guys don't know about sysinternals, you should definitely Google that. It's a ton of super useful utilities that they wrote. So PSExec actually allows you to run processes both remotely and locally. And so one of the things that is very, very useful from sysinternals is the capability of running the process in the system account. So that's the -s parameter that you see there on your screen. And the other thing that's interesting is running a program interactively with the -i parameter. So if I run PSExec -s-i, then I run SSMS. Hey, let's do this first. Let's run CMD. Just like a little quick CMD. Look, the other window, where I was running this on, was running on the my Argenis login, right? And if I execute where am I in this one, you can see that I am actually in the authority system now. Pardon me, which turns out to be an account that in SQL Server 2008-02 has sysadmin privileges to the box. Sorry about that. So since that account has sysadmin privileges on SQL Server, could I possibly leverage that account's level of access to hop onto SQL Server now? Well, how about you just execute SSMS from here? Okay. Notice how SSMS is now running as anti-authority system. Right? I can just hit connect and now I'm in, because again in 2008-02, anti-authority system is provisioned as by setup, and this is nothing that you should change. It's actually set up as sysadmin. So by assuming the role of the anti-authority system, I've basically hacked into my instance, and I now have full privileges, so I can create a new login and give that login the same permissions that I had before. So effectively, if I go into my previous one and I refresh, pardon me, I can now see that I've added myself and I have full privileges on the instance again. Right, so that's how quickly you get back into SQL Server. Sorry about that little cough. If you're a local administrator on SQL Server 2008-02, this is basically how you would do it. So let's try that on a SQL Server 2016 box, right? So what I'm going to do for that, I'm going to log on to this instance right here. And hopefully the demo will work. Now remember, like I said, in SQL Server 2002, anti-authority systems actually provisioned as sysadmin. Well, that is not the case from 2012 onwards. So what do you do on 2012 onwards? Well, if you notice, this instance right here is running actually, I'm connected to it as I say. If you look at the logins, you have a whole bunch of logins in there that have potentially some high privileges, some of them. If you look at particular interest, NT-Service and SQL Writer has sysadmin privileges to the instance. So could I possibly exploit that and hop onto the SQL Server instance by leveraging the SQL Writer service for that? Well, it turns out that if you run services.msc, you can actually see that the SQL Server DSS Writer service is right here, and that's the one that actually has that SQL Writer account that has sysadmin privileges. This is just a process, right? If you look here, it's just SQL Writer.exe. So what if we actually leverage this the SQL Writer.exe kind of or the path of this executable to run whatever we want? Would that actually be possible? So let's try it. What I'm going to do first is I'm going to get rid of my pure SQL or Genesis login to make sure that I'm not cheating here. And I'm actually going to disconnect, pretend that I don't have access to the systems whatsoever. So bear with me for just 1 second. All right. So we have the SQL Writer.exe path to the executable. Right? So where is that reflected? That is actually reflected on the registry. So if I run regedit, I can go into HKey local machine, system, current control set, services. I go to SQL Writer. There it is, the image path for SQL Writer for that particular service. So what I'm going to do is change this to something that's convenient for me. So for that, I have this little cheat sheet here. I just need to make sure that I'm running the right thing. First of all, let's figure out where SQL CMD is in this system. So for that, I'm going to go ahead and do the SQL CMD.exe/s. And it tells me exactly where SQL.cmd.exe is. So I'm going to go ahead and paste this in here. Change that to this SQL CMD.exe. There's more things that we want to pass to that. So those will be these things. We want to connect to the actual instance name and create my login from Windows and give that login sysadmin privileges. So this is, we paste that up. And we want to run this against SQL VM00, not VM03. So is it okay? And let's check that out. It's a pretty big, pretty lengthy command line execution. So that looks good. I think we can now test it out. So remember, I don't have access to my SQL Server anymore. Okay, I've lost all access to it. So if I wanted to connect to it, so there is engine here. If I go Windows authentication, my Windows login does not have permissions whatsoever. Okay, so look at that, no issue, no access. Okay. But now all I really have to do is just make sure that my process runs, my service runs that. So for that, all I have to do is just right click and restart my process. And it's going to error out and it's going to tell me that something failed. That's totally okay because I only wanted to run that one command that's running in there. I didn't expect this to like stay and run. So if I now go in here, I can actually log in with full privileges. My SQL Server login is now created here with full sysadmin privileges into my SQL Server instance. So this is what I mean when I say that local admin always equals sysadmin. There are more advanced ways of gaining access to SQL Server instance that you really don't have access to. I'm not going to go into a lot of details on those today because we really have a lot of content to cover, and I do want to leave a lot of time at the end for Q&A. But that's how, this trick that I just showed you works on 2012, 2014, and 2016. I haven't tested it on VNext, but I'm pretty sure that it works on VNext as well. And the other thing that I haven't come up with is a way of getting into SQL Server for Linux, but I'm pretty sure we're going to be able to leverage some account that has high privileges in the system to hop into them. So it's just a matter of time before we figure it out. Anyway, that was local admin equals sysadmin. Again, I showed you a way of getting into your SQL Server 2008 or 2 instances without ever bringing them down, because you can absolutely, put your instances into application mode and change the SA password and that sort of thing. But you don't have to do any of that with the methods that I just described. When you do that while keeping your instances completely online, which would be the way that you would be hacked. Right? So somebody's going to hop onto your instances. They're not going to bring them down. They would alert you. Right? They're going to be able to running. So anyway. That's really what I wanted to show you about that. So what's coming up here is network sniffing, right? So actually, so let's go back to network sniffing. This is a pretty interesting myth that's pretty widespread out there that says that SQL Server actually encrypts the connections between the actual client and the server by default, and it turns out to be it's a pretty big fallacy, right? So I'm going to show you how that goes by just running a network sniffer here on my infrastructure. So just 1 second while I launch this. So I'm going to use Wireshark here. And this is what I'm going to do. I'm going to actually start. I'm going to actually disconnect from this. I'm going to close this stuff. Right? Not connected to anything right now. I'm going to connect to a remote instance, but I'm actually going to start capturing packets here from my interfaces. And you can see that we started capturing. So we're going to go ahead and connect to my SSMS, but I'm going to connect to a remote instance, not the local instance. So I'll connect to CSLab, SQL, let's connect to SQL 00, which is fine. Just notice that I'm just going to browse around. Okay, I'm going to just look at have a bunch of databases in here, put some tables, and if I right click and give me like nation, right? It's not a big table here, and select the top 1,000 rows for that. Got some data, etc., etc. So what kind of information was actually captured between my SSMS running on SQL VM02 and my server running on SQL 00 by looking at the network? Was there anything captured in? So the answer to that is absolutely yes. So if we do this filter tcp.port EQ AQ 1433, then that's actually filtered out all the connections between my client and my server. So if I right click and say follow TCP stream, well, guess what I'm going to get? A whole bunch of unencrypted information. So look at that. I have actual T-SQL return. And if I keep looking, I can see, you know, what the server replies with. So I send the server queries and the server replies with data. And so this is kind of how you understand what kind of information is being sent across the network just by sniffing it, right? So this is, you know, a potential vulnerability really in your networks out there. This is why your network guides exist, and your network, there's actual network security in your infrastructures, right? To make sure that, you know, this kind of threats are not a problem in your infrastructure. But there are things that you can do to tell SQL Server to just go ahead and encrypt everything between connections. I wouldn't necessarily recommend that you go ahead and enable those features, because a lot of things may break in your environment, and that's just not a terribly good idea. Okay, so do some research, find out more about this if you're actually concerned that you may run into this particular issue in your environment. Okay, that's really what I wanted to show you about network sniffing. So I'm going to go ahead and cancel this and close this out, and then we're going to look at the next thing here, which is batch the hash. It's roughly around 20 years old, which is kind of amazing, right? This is one of the oldest attack vectors in mind, right? So something that's pretty interesting here is the idea that you can actually take a signature, a hash for a login, and replay it from another host. So here's the scenario that I want to show you here. I have this SQL Server 2008 toolbox, right? A lot of you guys still run this stuff out there. In SQL Server and Windows Server, this actually runs on Windows Server 2002. So it's actually pretty common to see people that are running this kind of software still, right? So if I just gonna show you really quick what the host name is. So if you look, this is the actual name of the host, the CS Lab SQL 2002, right? The domain name, right? You can actually see on domains, this you know, the actual user domain is pure SQL. Right, my username is Argenis, right? So it's pure SQL Argenis. So if you do a who am I, it tells you, you know, it's pure SQL Argenis. But imagine that I can actually get, you know, a hash for the an NTLM login, NTLM being one of the authentication protocols that you can use against SQL Server. If I can grab the NTLM hash for pure SQL Argenis and replay that from another machine that's kind of an evil machine, but then I can easily gain access to that. So here's the scenario, right? That's my box that I want to connect to. And this is my Windows 7 evil box that I want to kind of connect to my Windows Server 2008 toolbox from. So here's the trick, right? This is actually called, I'll show you in just a second, the computer name, it's pure SQL, which is interesting, right? So pure SQL is my domain name on the other computer, right? And my login here is Argenis. So who am I returns pure SQL Argenis, because pure SQL is my computer name, not my domain name, and it returns Argenis as my username because that's indeed my username. Okay, so if you look here, there's no actual domain. This is a workgroup. Okay, so if you notice here, this is an actual workgroup. This is not connected to the domain. So this just happens to be on the network. So what if we were able to grab an NTLM hash from pure SQL Argenis, the actual administrator on the network, and then replay that from this kind of evil machine that's sitting on my network? Well, how do you go about that? This is a lot easier on Windows Server 2008 than it is on newer operating system versions. So that should tell you how important it is for you to keep up to date on OS versions. So there's something called WCE, which is Windows Credential Editor. And if you run that, this is actually something that will get you fired. I'm not kidding. If you download this and start running it on your computer right now, somebody will probably show up at your desk and get you fired. Okay, this is a huge security flag that will be raised by just downloading this. Right? Even the regular Windows Defender antivirus today marks it as unsafe to download. So anyway, if you look here, Windows Credentials Editor dumps the entire NTLM hash table for all of my logins all the logins that are currently in my have been established against this machine. So I could potentially just take this and edit the credentials for my Pure SQL Originalis user on the auto box, right? So if I go to my Windows 7 Evo box and I run WCE in here, you can see that the hash doesn't match. But if I do WCE, actual command is -S, right? So -S changes NT11 credentials for the current login session. So I can actually say WCE -S, paste what I, oops, sorry. So then WCE -S. And I'm gonna go ahead and grab this stuff from this machine right here. I'm gonna paste it on the other one. I'm gonna touch the last line that I did not copy. So I do that. Notice how it changes the credentials for my Pure SQL Originalis login, which previously did not have access at all to my domain connected machine, but now I can just click on something, connect to a machine that's actually in the domain, and I can log onto it. Right, so that's basically stolen and in replaying an NTLM hash, and now I have full access with sysadmin privileges and local administrator privileges against this particular SQL Server instance that I am now targeting. So this is how dangerous fast the hash can be in your environments. This is something that gets mitigated by security folks. So as a DBA, you should just refer to your security person and make sure that this is not a problem in your environment today. A huge red flag will be the continued use of Windows Server 2008 or 2 and Windows 7 in your environments. Because these are outdated operating systems that are plagued with holes, and they're very vulnerable to a myriad of different scenarios. Okay. So that's past the hash. So I basically logged on to an instance that I had no privileges against whatsoever, just by replaying credentials stolen from a given host. And so there's actual ways to capture NTLM hashes from the network itself. So you don't necessarily have to log onto a Windows Server something or toolbox. So I'm not going to go into this methods right now, but there's always ways of capturing credentials out there. Anyway, that was fast the hash. So I'll leave you with for you guys to digest that after the fact. You can watch the recording and see what I did again over and over. The last thing I really wanted to touch upon before we actually open it up for Q&A is just finding more undocumented stuff, right? So SQL Server is the best. Things are always undocumented. Again, there's all the things that you can learn about it that are fully documented, blogged about, et cetera, et cetera, et cetera. But the best things are the undocumented things that no one really has bothered to document, or because Microsoft won't support them and that kind of thing. So one of the ways that I show people how to find undocumented stuff in SQL Server is simply by using strings. Okay, so strings.exe, it's a pretty common utility out there. Let me see where I have it. I believe I have it available here in this box. Not on this one, but maybe on 00. Hold on one second here, guys. So I go to my bin drive here. I think I have a copy of strings in there. Nope, maybe my one box. Sorry about that, guys. I don't know exactly what. Can't remember exactly which box has a copy of it. All right, never mind then. So strings.exe, I do have it in my bin directory on my laptop here. So if I run strings, you can see it's another utility from sysinternals, and that actually, it takes anything from a binary that looks like a string and basically outputs it. So you could potentially just run strings.exe against a SQL Server executable, or even SQL Server running in memory. And that way dump anything that remotely looks like a string into a text file, and from that text file, you could do some pretty interesting searches, right? And I believe I have a folder here that dumps. Okay, so here we go. I have all the SQL Server TXT files in here. So I'm going to open those. I'm going to close the stuff that I don't need here. So bear with me for just 1 second. I can do searches across all documents here. So you can see there's SQL min.dll, the SQL dk.dll, and the SQL lang.dll. Those are DLLs that belong to the SQL Server kind of executable framework, right, if you will. And so the way that I search for undocumented stuff is by perusing through this, right? An interesting thing, if you look for something like freeze.io, you can see here that this is basically a bunch of DBCC commands, right? Freeze.io is one of the rather undocumented commands of DBCC commands out there. But if you look here, there's a whole bunch of them, right? And across all of these, they even come with help. So Microsoft was really nice to bake in a little bit of help for those in there. So it kind of gives you an idea of all the things that you can run that Microsoft really doesn't want you to run. So obviously not going to spend any time on any of these today because we're basically running very low on time today. But it gives you an idea of the interesting things that you can do just by searching for strings anywhere. And there's actual, in SQL Server 2000, a way of dumping the SA password would be by actually having somebody connect with the SA password and then dumping the memory of the SQL Server .exe process and running strings against that. It's kind of another way that you can kind of get yourself in trouble and steal somebody's SA password. Anyway, that was really what I wanted to show you today, guys. I'm gonna open it up for Q&A now that we have about 6 minutes to the top of the hour. Anyone with questions?
Got one comment for you from Renato Keibel. Just says, very cool, the part where you added yourself to sysadmin. And just got a question in from Alvaro Costanito asking, where do I get WCE?
So WCE you can obtain from the internet, Google it, WCE, Windows Credential Editor. Like I said, that can get you fired, all right? So be careful where you download that stuff. I don't want to be responsible for anybody losing their jobs today, okay? Be careful what you download into your computers.
There was a question that came in also from John Hohengarten asking about who it was that had written the SQL to convert road log contents. And so I just sent out to everybody the Twitter and blog links for Patrick Flynn, who is the person you said that wrote that. So that message was sent out to everybody. Brett Collins says, good presentation. Thanks. Renato Caivo says, we traditionally remove NT authority from sysadmin. Is there a better way to protect SQL?
If you're removing NT authority system from the logins, you're basically becoming, that's an unsupported scenario. NT authority system is actually leveraged by things like failover clustered instances for the is alive and looks alive kind of tests performed for that instance to make sure that it's up and running. So it's a non-supported scenario when you remove NT authority system. However, if you know what you're doing and you're not running on a cluster, you may get away with murder and just delete that account. Yeah.
Great. And Nathan Arnold asks, in your opinion, is Kerberos worth implementing? Lots of...
Absolutely, 100%. It's a pain in the butt. Like everyone knows that. It's hard to debug. It's hard to go up and running. It's brittle, but it's way more secure than relying on NTLM, and way more reliable than running on the newer versions of NTLM. Okay, so just don't try to avoid NTLM like the plague if you can.
Nathan also says thanks. Alvaro Costanito asks, would I use Kerberos by creating SPN for SQL?
Well, that's one of the many things that you have to do in order to make sure that Kerberos authentication takes place with Kerberos. And unfortunately, we don't have a lot of time to talk about that here, but that's actually an extensive area of discussion. And so I would suggest that you search on these topics. There's plenty of information out there.
Yep. I would add that there's a long list of things you have to do, and that's one of them. And
you're right.
And several people are asking if you are going to make your scripts available.
Yep, I can upload those to the Security VC archives. I'll provide those to you guys, and then Robert, hopefully you have a means to put them up.
Great. So we'll put them on the meeting archive along with the slide deck and the recording.
Any other question?
No more questions at this time. So thank you for presenting for us today, Argenis. I know you're traveling, so really appreciate you taking the extra effort to present while traveling.
Hey guys, thank you very much for having me today. I apologize for the background noise and I apologize for the little cough that's still lingering here. But hopefully this was fun and entertaining for everyone. Before I wrap it up, I just want to say thank you all again. And here's my contact information. So, shoot me an email or just follow me on Twitter at ddrgenis. My more security conscious blog is sqlblog.com. It's listed there. And then my storage focus blog is there at the bottom at purestorage.com. So you will get access to the slides and you can, just click on those links there, right? Thanks, guys. Appreciate your time today.
Thanks to everybody for joining.